Hi, thank you for joining us. This is the Big Data as a Service panel, so if you're looking for something else, this isn't the right one. My name is Tuan Do. I run the National Security Programs at Red Hat. And today we're going to talk about Big Data as a Service. And first I want to start with a preamble about data as a first-class citizen. Back in the 70s, we built applications and then we modeled our data into those applications. And we lost a lot of data because we weren't tracking it. Now, because we treat data as a first-class citizen, we build applications on the fly using open source technologies, and we treat the data as the first-class citizen. So let me give you a very good example. The music that was being piped in here was from a service called Pandora. As an end user, I don't care about the application that's delivering it. By the way, it's Red Hat storage. But I do care that when I want the Beatles, I get it immediately, right? And so what we have assembled today is a very distinguished panel of people from the government, people who've been working in the government, people who have been working in the government as partners, and have been solving big data challenges throughout the government. So the first person is Chris Layton. Chris Layton's from the Department of Energy. He'll be coming to talk. The second person is Javier Hughes. Javier Hughes is from the Department of Labor. He'll be talking about how we use labor statistics. The third person is Dr. David Bauer. Dr. David Bauer is the CTO for Data Tactics, was the chief architect for DSIG's cloud. And then the last person is John Kreisler. John Kreisler and I go back a long time, but he's the chief marketing person for Hortonworks, a open source Hadoop platform. So what I thought we would do, just so everyone knows the platform, each panel member will come up and deliver about 5 minutes, and then we'll have a Q&A, a formal Q&A, and then we'll open the floor up to questions. So without further ado, Chris, you want to start?
Sure. I want to start off today and talk about a big data initiative that we're currently developing at Oak Ridge National Laboratory, where I work. What we're looking to do is have a scalable data infrastructure. And what that means to us is where we will be able to take, for those of you that don't know, we have supercomputing efforts, clustering efforts, and various other efforts at the laboratory. And what we're wanting to do is take those and roll those in to sort of a centralized project. And by this, I mean users will be able to come to a self-service portal and be able to provision resources. And the type of resources that they'll be able to provision will be things like petabyte Lustre high-performance file systems when they need performance. They'll also be able to access NFS storage for things like home directories and general use storage. And they'll also be able to access our 100 gig pipe to the internet, which will allow them to do data transfer as well as access remotely. They'll also be able to tie in to some of our resources that are available for researchers at the lab, like our 145 petabyte HPSS archival storage system, as well as our Everest visualization wall, which I'd like to jump into right now and talk about because I think it's a very exciting technology. We've actually recently upgraded it. Unfortunately, I was not able to get a picture in on the slides of the upgraded wall, but it is a very impressive resource. If I could get the first slide.
We're working on
it. Okay. I could tell jokes or...
How's your tap?
Real quick, some of the things we're doing currently is like climate modeling. That's things that we're sort of very well known for. Project Enterprise is doing climate modeling where they're doing automated workflows on the Titan supercomputer, writing that out at very fast speeds to our currently 10 petabyte, soon to be 28 petabyte Lustre file system. And then they take that data and they analyze it at various locations throughout the lab, sometimes on a compute cluster, sometimes on other resources in their department. And then they take this information and they're able to visualize it. The first slide you're actually going to see, I'll start talking a little bit about the Everest wall. Everest is actually 2 screens. The first is sort of your standard big screen. It's about 16, it is 16 display monitors doing your standard 16:9 aspect ratio. Brings data to life, really adds a lot of resolution. But something that we've found that is even more exciting, especially I've gotten several demos over the last few years of this technology and have gotten to see it evolve, is the main Everest visualization wall. Now this is approximately 30 feet wide and 8 feet tall. and it is able to visualize data at a level that most people just can't. I mean, until you see it, you almost can't comprehend it. The new wall, just to give you some stats while they're getting the slides up, is a 37 megapixel, 18 panel networked wall that also has all of the color set up. For those of you, and I mean, a lot of people have analyzed data before on 2, 4, 8 monitors. Imagine that, taking those 8 monitors and scaling it out to an IMAX in high resolution. The new wall is also able to do not only standard 2D, which you'll see in the second slide, but also 3D, and this is a new feature. This is not the 3D that you're going to go into the movie theater and put on the glasses. You do put on some funny glasses, but they are a lot more advanced. This is active stereo. Traditional 3D only has about half of the color range. This is full color range. I mean, you don't want to view data with half the color palette disappearing. So, and also something that is very exciting that's really new that we're currently working on is positional 3D, where you're able to put on some very funny glasses. It looks like you have little antennas sticking up, and you're able to stand at a point in front of the wall, and you're able to actually integrate with the data from different angles. One example they gave was a cellulose stalk where the researcher was able to actually see it, the image, a single image from multiple angles. So you're able to add that extra dimension to your research and visualization. We still having trouble with the slides? If we do get them up, the second slide actually is going to show 1,000 climate models being rendered on the wall. And this is actually on our previous wall. The wall is powered by a Linux cluster that does rendering and scaling on the wall. But we've also added a feature where users can come in on the new wall and plug in to VGA ports located throughout and display data off their Mac or Windows or Linux laptops. So this is actually a new feature that opens up the resource to a lot more users. We've found that researchers that utilize this wall are able to visualize climate data, fuel research, and various other types of science at a scale that is just unbelievable. If we do get the slides up, I can comment a little bit more. If not, that's about all I've got.
I have to come back to you.
Okay.
On the slides. So, since we don't have slides, Dave, do you want to go next? So.
I have no slides, so that makes mine easy. Low tech always works. My name is David Bauer, and I have been a systems architect now for about 20 years, and about 10 years ago started getting involved with big data, what we called at that time cloud computing. Cloud's kind of morphed into virtualization, which is fine, but you know, working with the military, working with the intelligence community, we've been able to tackle and solve a lot of big data challenges, some of which you've seen in the news over the last couple months, and been able to tackle them at unprecedented scales and generate intelligence for our customers that have heretofore been impossible to generate. You know, let me start with back in 2005, I had a crazy guy over at DISA, CTO office, who turned to me and said, hey, let's go around and let's just go talk to everybody in the industry about what they're doing in the field of big data and cloud computing. Let's go see the guys at Google and see what they're doing. Let's go see the guys at Yahoo, Microsoft, et cetera, and see what's going on. That's at the time where I got a chance to meet and work with guys like Matt Olson, who later went on to found Cloudera. That's where you know, a lot of the new ideas came out. That's probably about the same time where CloudForms probably started to get developed, is 2006 and 7, based on some of the ideas that came out of Yahoo Labs. You know, we did some really nice work in terms of building one of the first big data platforms, to my knowledge, in the federal government in terms of understanding what this new paradigm was all about. Then in 2008, we were approached by the Army of all places to build an Intel platform to replace all of their Oracle-based systems around the world. That was a program that I got very excited about. I was a tremendous opportunity to deploy an Intel platform for the intelligence community, leveraging Hadoop technology. The program manager at the time had basically sat us down on day one and said, you know, regardless of what the key performance predictors are, first and foremost, the drive has to be towards open source computing, towards open source technologies because the rate at which the data is growing on the battlefield is unsustainable. We can't afford to keep putting analysts in the field. We can't afford to keep building more and more of these databases and putting them out there. That culminated in 2011 with the first publicly acknowledged instantiation of a big data platform in the entirety of the federal government. We actually announced that on both SIPR and coalition networks in the same month at the beginning of 2011. Since that time, we've been extending big data now to encompass and include your traditional cloud virtualization technologies. And one of the things that we're doing that's very exciting for our customer down in Florida is we're actually running OpenStack on top of a big data platform. And we're getting a lot of benefits from the integration of the two technologies in terms of business continuity, continuity of operations, as well as just the day-to-day replicating data around the world. So in particular, Red Hat has been a strong partner. When I was asked to do this, I absolutely wanted to be a part of it. Red Hat has been a core foundational technology from the very beginning in terms of the operating system, in terms of the JBoss middleware, as well as their messaging services, and the technologies are too numerous to mention. RDO, for example, is our preferred.
Yes, Chris.
Now that is the smaller wall. The larger wall, this is some of our researchers using the Eden environment, I believe. Yes, the Eden environment to do data analysis. Now the Eden environment is a publicly available piece of software. It's primarily used by Chad Steed and various others of his associates in climate research. But if you'll hit the next slide, you'll see. There it is. That is 1,000 simulations viewed all at once. Now the wall is actually laid out where you're able to stand about 12 feet back and you're in a perfect focal alignment with the screens so that you're able to take it in, and yet it's at not such a large resolution to where it's unreadable or understandable. It's very immersive. Now this is the old wall. The new one is a little bit bigger, but it's basically the same effect. Now imagine taking that to 3D where those lines are jumping out at you. It's a very impressive resource. Also, one thing I wanted to touch on in our big data initiative, which is called CADES, what we're looking at doing is taking not only a traditional clustering environment, which a lot of our researchers are already familiar with, but I mean something that's very difficult to do is it's very difficult to provision resources. A new project comes in, you got to stand up infrastructure, you got to stand up compute, you got to stand up storage, you've got to help them scale out their code. So what we're trying to do with the CADES project is sort of consolidate those services to a user portal where the user can come in and provision their own services and use shared resources. Now you would have not only the traditional compute cluster, say 1,000 cores, but you would also have an OpenStack environment where you would be able to provision something as simple as a web server to display your data out to the world via the 100 gig pipe, or even Hadoop, where you could go in and do data analysis. And that would all be able to be provisioned by the user. So that's, I think that kind of speaks for itself. But yeah, Chad Steed's doing a lot of work with Eden and Project Enterprise to be able to do climate analysis. And I mean, this doesn't even begin to do it justice. Imagine a wall of monitors bigger than this wall behind me, and you would start to get some idea of the scope of the visualization. And it is, I mean, watching the researchers interact with the data. I actually work on the floor where this is located, and you'll walk by and you'll see the guys, and it's just the amount of data they're able to process in such a short period of time. I mean, I think this is in the big data picture when you're talking about, well, you know, you can create the data, but how do you visualize the data? How do you actually process large data sets quickly? And I think that the Everest resource at ORNL is proving to be a strong contender in that arena to be able to do that type of processing.
Can I borrow that?
That's amazing. Super Bowl party. Can you go to the next slide? Is this you?
Yeah.
Javier.
They might have a big monitor by half the world. right there. You see that? So my name is Javier Hughes. I work at the Department of Labor, and it's really, really great to be here. Thank you for coming and to listening to my not so technical spiel compared to these two geniuses. So I'm going to bring it back to a very high level and how big data, open data really impacts the Department of Labor and how we do things each and every single day. The way that we've gone about it is we've tried to liberate as much data as possible over the past couple of years. We've actually developed a dedicated platform just for individuals and businesses to use our data, our enforcement database, which we just upgraded. You can find all kinds of data there, including occupational safety and health, mine safety and health, Office of Federal Contractor Compliance, so behave. You know, all kinds of really, really good stuff, employee benefits, security, retirement, pension retirement related information, all kinds of things. So what are folks doing in response to this? They're actually starting businesses, really, really cool startups around some of our data. There's one that's focused around benefit security, and then there are a couple on their way around actually mine safety and worker safety in around the hotel, motel, restaurant, and retail industries. How does this impact us from an internal point of view? So I've discussed a little bit externally, how the type of data that you can find and how you could monetize it. We're giving it to you for free. How you can monetize it after we've cleaned it up. But internally, what big data does for us, it helps us be more efficient in the way that we manage the department. We have over 20 agencies. Several of those are enforcement focused. And how can we do more with less? How can we focus on on programs that provide a higher return on investment? And how can we tighten things? So through the use of our internal big data, we do beyond. We started with quarterly reviews. We actually go on a biweekly basis, and we take a look at everything that's really coming in and is being processed, and we tweak our strategies and tactics around what we should be doing. And to us, that's been really a blessing because we are able to once again do more with less, especially during some difficult times, and do more justice to our actual taxpayers. So that's a lot of what we're doing. Back to the external side of things, there's some keywords here. Triumph through crowdsourcing and innovation through collaboration. We've worked really, really, really hard to build effective public-private partnerships using our big data and building really efficient working groups using nonprofits, academia, for-profit organizations to tackle really interesting issues. Some of the most critical issues that we've tackled are equal pay, providing proper wages for women in the workplace. That one's we were able to get back some fantastic applications using some of our data, partnering with salary.com and using their big data that they opened up for free to the rest of the public to be able to generate some of our applications. So all this obviously requires a great deal of internal sophistication, security, ensuring that things are done correctly, that there are the right processes and in place. So I try to not focus on specific vendors, but I can, vendor names, but I can tell you that we wouldn't be able to do this without their collaboration, their participation, and that means that we wouldn't be able to get as much juice out of our data, and the American people would not be able to generate, their own startups without these kinds of services.
Thank you. I think the next slide will be for John.
Great, thank you. So John Kreisa from Hortonworks, also very excited to be here today, and thanks, Tuan, for inviting me onto the panel. Hortonworks is a company that develops, distributes, and supports a big data open source technology called Apache Hadoop. It's an open source data management platform. Can I just see any familiarity with Hadoop? I just want to sort of get a sense. Good, thank you. About half, actually. It's good. So what I thought I'd do, I'd also keep it at a fairly high level like Javier, and just talk a little bit about how Hadoop fits into the infrastructure, a little bit about what some organizations are doing with it, and the kinds of data that are being processed. So firstly, the big data and the data that we're talking about that's being generated by various organizations is putting a lot of pressure on what we'll call the traditional enterprise infrastructure. So this very simple diagram that I sometimes refer to as layer cake is representative of the kinds of infrastructure that almost all organizations have in some form or fashion, and it's been developed over 35, 40 years for collecting structured data of some form or fashion and processing that and analyzing it with a wide range of tools. And the data that is the data growth, which many of your organizations might be experiencing, and is certainly representative of some of the things that we're seeing here, is tremendous, and it's the amount of data that will double every 18 months roughly that is available in the world. Much of this data was considered exhaust data. It was considered data that previously wasn't really valuable to the organizations, and more organizations began to see this data as having value and beginning to want to capture it. But that put a lot of pressure on this traditional infrastructure. So, for example, 15x machine-generated data growth by 2020. So just a tremendous amount of data flowing off of devices and sensors. So it's a huge data growth, putting pressure on the organization. So next slide. Who's got the clicker? So I just want to talk a little bit about the kinds of data that are being collected. And I think you'll see that there might be a kind of data that you can represent. And what we've done at Hortonworks is, just in terms of our engagements with our federal and government customers in general and with our commercial customers, we've seen characteristics and categories of data that people want to use and exploit with Hadoop. And that's really what it allows them to do. So sentiment data, you heard a little bit about sentiment, how people feel about a service that's being provided, comments and rankings and ratings and all the different ways that you can express sentiment about a service or a product or some kind of offering. Clickstream data that's collected off of what somebody's doing when you're interacting with them on a website. So collecting all of that data to understand not just what was the click that generated the either a purchase or a transaction or some kind of activity, but what were the 10 clicks that happened before that? Allow me to be predictive and proactive and understand. So clickstream data, sensor machine, almost everything has a sensor, whether it's energy systems that are generating power or monitoring systems or video systems or what have you. Tremendous amounts of machine generated data. Geospatial data, where is something occurring? Where is a service being delivered? Where is somebody searching for that activity? Server logs, so coming off of applications, just log file data that any one atomic piece is not that valuable, but large amounts of it can give you ideas of what's happening. And then unstructured video and text. So all of those types of data are data that we're seeing organizations want to capture with Hadoop. That's what they want to use it for, in addition to keeping existing data online longer. So in the existing infrastructure, there's still costs, substantial costs related to keeping data online, but Hadoop gives a low-cost way for you to continue to keep that data for 4, 5, 6, or even longer online so that you can continue to analyze that alongside the existing infrastructure. So this is some of the data types. If we can get the next slide, please. What that does is it informs us that there's an emerging data architecture where Hadoop is a component where it is complementary to the existing infrastructure, and it allows organizations to capture these existing emerging data sources, interact with their existing structured data warehouses, databases, those like components that are already in the system, and then build new kinds of custom analytic applications that they weren't before. So there's really two ways that this helps. One is they can build applications they simply couldn't before because they can capture that exhaust data and combine it together with other types of data, giving them new kinds of insight that they couldn't generate before. That's one. The second is an optimization of the workload. So often these kinds of data are being processed in one of those structured components in a data warehouse, and it makes more sense economically to do that processing in Hadoop. So it's modernizing that architecture and putting the workloads where they should be, and building net new kinds of applications. So let's look at a couple examples. So formatting came through pretty well here. So for example, and this, it actually goes back to the data. So I wanted to make sure for each example, I specifically talked about the kinds of data. So law enforcement and security, store and processing large amounts of biometric information, right? So it can be collected in a wide range of methods, all put together and combined inside of Hadoop in order to increase the accuracy of IDing suspects and targets and things that they would do with that. So whether it's image data, facial recognition, fingerprints, audio data for voice recordings, all of that different information can be collected in one single central repository, and an application can be built to run and analyze that data. EPA, capturing machine-generated data for coming off of sensors, right? Wind turbines and floodgates and dams and all of the data that that's being generated by machine-generated data by the EPA can now be easily collected and then analyzed with Hadoop. And then finally, the Social Security Administration using it to collect and find fraudulent claims by collecting all that big data. So Hadoop itself provides that platform. I think is maybe clear to do data as a service, to build new kinds of applications where you couldn't before.
Yeah, I think my favorite big data story is there's a bank out there that, and I won't tell you which one it is, but that says that they can predict whether you and your spouse are going to get divorced with Javier and to Chris. What can the private sector learn from the way the government is incorporating open source technology or big data?
Yeah. I think that the private sector, I mean, let me start off and say that this is probably going to make a lot of people in this room happy. We are 99.99% Linux in my division. We are complete adopters of open source. I've worked in a Microsoft environment. It's been a decade or so ago, but I have had exposure to the Microsoft environment. But big data is something that a lot of people sometimes have to find what niche best fits their environment, and that's very difficult to do. And it's something that at Oak Ridge we're trying to be able to, from a research perspective, we actually have people on staff that allow people to come in and learn how to scale their code and learn how to optimize for our environment. So they're able to take something that would run on a desktop machine that would take months and be able to scale it up and integrate it and analyze it and then visualize it all very quickly. And a lot of what we do, especially in certain workflows, is open domain. A lot of what I support is open science. So a lot of this stuff, like the Eden environment, is out there and available to the public. And I know that Chad Steed would be very excited to hear that somebody is using it and that they want to learn how to use it in their workflow. So we contribute quite a bit back to the open source community, both in tools as well as in information. I know that several people from my group, myself included, contribute to the open source environment as far as infrastructure support and scaling and things of that nature.
One thing that you can probably learn is that we've done as much as we can to date to ensure that you can not only absorb, process, and understand our data. We've really focused on things that are beyond the obvious, beyond the APIs and SDKs and sample code for multiple mobile platforms. What we're venturing into right now is into the world of GitHub, sharing all of our code, well, as much code as possible, and then also partnering with Code Academy. So like that, we can provide classes on how to build applications using our data. The reason why we're partnering with them is because if you're not a wage and hour expert and you're trying to build an application around wage and hour, and you want to provide that as a service to a specific type of business to ensure that they don't break the law or all kinds of things, right? You truly need to understand the wage and hour laws. So a data dictionary is not going to just solve that puzzle. By providing and by building these courses through Code Academy, we're able to solve that puzzle and provide a better understanding of how you can build these things. So we've also built discussion groups, and once again we've reached out to hundreds of developer networks to ensure that we're able to be as responsive as possible in the type of data that we provide, in the format that we provide it. And we receive feedback all the time. I deal with folks from the large search engines to the much smaller developer networks, and how we can fine-tune our public-facing data.
So my next question is for Dave and John. It's an inverted question. What can government learn? Because you guys have a lot of exposure into what the private sector is doing. What can the government learn, or what problems can the government solve based on your experience with big data and the technology tool sets that you have?
Sure. I would say that the biggest challenge that we face with the public sector, with the government, is their slow rate of adoption of the open source community, of open source software. There are certainly organizations that are very quick to adopt. There are some that have no choice. For example, understand the DOE very well. They really don't have a choice. But then there are a lot of organizations within the government. I hear this every day. There's no support. It's not ready. It's too mission critical. All of which are really, in my opinion, a very they demonstrate a lack of understanding of what's being missed by adopting the technology sooner, right? So it's possible within a lot of these organizations to adopt this technology early, rapidly, and get a lot of the benefit out of it without it necessarily having to disrupt your production quality systems and services that you have to operate as a part of your mission.
So I would say, I think probably building a little bit on that, one of the things that I think the government can do would be to participate, particularly in some of these open source projects like Hadoop and others. There's actually a fairly high pace of innovation, and the more people, of course, that participate, the faster that innovation will occur. There are some good examples, I think. For example, there's an open source project called Apache Accumulo, which is a columnar database based on Google's Bigtable implementation. I'm trying to throw too many terms out, but basically it's an open source database that we provide. Hortonworks happens to provide support for, but came out of the Fort. So they had very specific government requirements around security and performance, developed that project, but then put it into the open source community. And I would encourage more of that kind of thinking out of the government to help increase the rate of innovation in open source.
I think one of the biggest misnomers of open source is that it's not mission critical. If you think about how Google came to market, they were the 19th search engine to market. Imagine you coming out with a product that was the 19th one, like Alta Vista. Anybody remember that as a search engine? Google was the 19th search engine, and within 2 years, using open source technology, it became the #1. If you don't think that their open source technology strategy is mission critical for Google, well, we probably need to have a different conversation, right? Because that is what they do. And Hadoop is spun out of a white paper that Google produced. So I want to open up the floor to some questions. We have a few minutes for questions, so we'll entertain questions, sir.
Javier, for you. Sounds like you guys have taken data.gov really to the next level, really what it's really meant to do.
You know, there's a new version of data.gov coming out soon.
You were speaking it to me, whereas you said you take data from companies and bring it in to yours and develop applications. Now, let me ask you, do you liberalize your data that you have by developing web services?
So actually, we don't bring in private sector data. Okay, that's private sector. What the private sector does, and academia, any kind of nonprofit, any non-federal group or federal group can actually pull our data through our web services. So most of our data is public facing. As a matter of fact, there's very little that is not. For example, our management data isn't, nor should it be. But the actual, anything that's related to enforcement, anything that's related to grants, employment and training, licensing, credentialing, veteran training, tools, military occupational translators, things of that nature, everything's available through web services for free. You can grab that code. It's free to just, you copy, you paste it. You can call it Joe's military occupational translator, and it's yours. And that's free, free of cost. So we are offering all that, but in order to, one thing is to offer it. The other thing is, are people going to use it? Going to use it? Can't guarantee that people are going to use that stuff. So that's why we've worked really hard in building these type of relationships with non-federal groups to ensure that they can amplify our mission and then help meet our goals, right? That's why we've launched multiple app contests in addition to all the outreach stuff we've done, focused on occupational safety and health, focused on disability employment, focused on a ton of other areas because they're able to do things that we can't do.
I have one more question I forgot to ask you guys. And I think it's a question that's pretty prevalent downstairs. What would you like people to tweet about this session?
I mean, going off what you said, big data is first class.
All right.
Big and open data creates new businesses. Job generators.
So I'm a big data guy. I think what I'll do is I'll share with everybody my favorite open data database that's out there. It's New York City, part of the New York City Open Data Project. It's the rat sightings database. So they online for free to everybody in the world.
John.
Well, I can top the rat database, but I would say just something that's probably tweetable is, open source and big data go hand in hand. I mean, they absolutely do. These technologies are something that everybody can take advantage of and really enable data to be taken full advantage of.
We have time for one more question, and the gentleman in the back.
So at Oak Ridge, where you have all that petascale supercompute horsepower, and then you have 160 petabytes of archival storage, how did you come across the tools that you currently use to really manage the real big problem is how do you move the data across the infrastructure from the supercompute, the massively parallel workloads, to the application layer, up to the presentation layer? Like, how did you guys, was it plug and play? Did you just cause and effect, or how did that work?
I could go into a lot more technical detail. We're kind of getting close on time, but we actually have data transfer nodes. We have a scheduled class, which is run off of the supercomputers, where it's sort of their workflow, where when they create a job, the job finishes, and then it moves the data either to archival storage or to another location, either remotely or locally. We also have an HSI node that is meant for interacting with the data that's in the HPSS archival storage. And then we have interactive nodes where remote users at facilities can come in to the lab with an account and access, of course, and be able to access their data that's stored on the Lustre file system. So they can move it from HPSS to Lustre, which Lustre is a Scratch file system, which I find it hard to believe that we have 28 petabytes soon of Scratch file system. But people are able to use these data transfer nodes to move the data around both internally and externally.
I'm getting the ping from our moderator in the back that lunch is ready. So we invite you to go downstairs to enjoy lunch on the 7th floor. I think you guys will be available if anybody wants to come up and talk to us. But thank you.